Hello and welcome to my first ever Advent of Code walkthrough for day 16 of the Advent of Code of last year. It's now the 26th of January, only 1 month and 1 day after the final day, but I finally finished all of the puzzles and I would like to go through an explainer video of Advent of Code day 16 2022. So, what is it about? Well, I have renamed it as the Mario Bros. Valve Madness. That is because... So, what's the problem? You find yourself in a cave, and the cave has a network of pipes and valves. And your puzzle input is a scan of all the valves with the flow rate. So if you open up one of those valves, you have a number of liters going through, a pressure per minute that goes to. And you have to find the path that gives you the highest rate of total flow. It takes 1 minute to open the flow, you have 30 minutes total time, and your goal is to obtain the maximum total flow rate possible. So, let's have the example. Let's look at the example where we have a few valves. I will show it. So we have valve AA, which has a 0 flow rate. That means if you open up, it won't send out any water. Then we have valve II, it's another one of the 0 flow rate. Then we have some more significant valves like BB that has a flow rate of 13, and it is connected to valve A with 1 step. And by the way, valve AA is connected to II in 1 step, and it means it goes backward and forward. Then you have here another valve DD that has a 20 flow rate, and a CC which has 2 flow rates, and you can get from C to B, and obviously from B to C and back. Then you have EE which has a flow rate of 3 when you open it, and then you have FF which has another flow rate of 0, so it's better to put that as a green valve because it doesn't matter what you do there, but it doesn't give you any gain. And then you have GG which has another flow rate of 0, but in the end if you go through that way you will find an HH which has a flow rate of 22, so that's not bad. If you want to have the maximum gain, maybe we should consider all that part. But how do we approach this problem? So as you can see, there are connections. I forgot one. In the example, there's also a JJ, which has a 21 flow rate. So this is like the schema of the of all the valves and the tunnels that connect them, and how much is the flow rate. And I've put that in a nice PowerPoint, and here we are. So, as you can see, not all the valves have a flow rate, so we should consider only the ones that have a flow rate if we want to maximize our output. And when you open a valve, the output is minutes left and times the flow rate of that valve. So if you start at the minute 1, you start at AA, you could move to BB at the cost of 1 minute, and then open valve BB. That will give you a total flow of 28 minutes, because you have to move there in 1 minute and you have to open it in another minute. So when you start at 30 minutes at the beginning, then you will have like 28 minutes left of this valve with a flow rate of 13. That gives us 364 total flow. Okay, that is a scenario. So what's the approach? Well, the approach is what we call a sort of a broad first search, a flood search, and we are solving this problem with Progress OpenEdge. Now, just a word on the Progress OpenEdge. Can you put a little bit up? In Progress OpenEdge, it's a language. It's a very powerful language, but the way to approach it in OpenEdge 4GL is by using temp-tables, temporary tables. That is a storage in memory, and if it's too big, it will go to disk. So you always have your total records available, and you have no limit. And it is a table, so you can have an index. It can be unique or it can be non-unique. And you have attributes. And in our situation, we want to approach this with two temp tables. One is containing all the valves. So a temp table with all the valves and how much is their flow rate, and a temp table with all the paths between the different valves. So let's look at the code. We start off with the temp table for valve. As you can see, it has a unique key, the valve, which is a character, which is like the two letters that identify in a unique way the valve. And then we have the path, which says if you go from one valve to another valve, it will take a number of minutes. Now that means that we want to calculate that from every valve to every other valve, and we have to first fill that temp table, because you only get the information for the single step valves. So, well, first of all, yeah, the input, it's always how are you going to parse the input? Now, if you have looked at the input, I can show it to you. So the input is like this. It shows you a line that says, okay, valve AA, so that you can extract the key from the valve, and it has a flow rate equals 0, so that is another key information. And then the tunnels from AA that lead to DD, II, and BB. So that's another information that we can make from one line of input, one record in the valve temp table, and a number of records for the path, for the single step path. You can look at the input line as one big string, and then you can go character by character. That's one way to parse. But you can also consider the string input as a list, and in a list you have a separator, and you can use any character as your separator. So if you use the space as your separator, then you know that the second element in that list is your valve code. So you can use the entry 2, which means second element in your list, divided by spaces, that's the separator character, and you use that as your key for the temp table. Then the flow rate is a little bit difficult, because it is like 1, 2, 3, 4, fifth element, but in the fifth element you have to cut off the dot comma, and we do that with the trim. So you can see there's a trim command. So we take the fifth element from the list, which is rate equals 0 dot comma, and we remove the dot comma with the trim, and then we also have to get the second element. Considering rate equals 0, we use the equal sign as the separator, so that we know that the second element in this sub list, that is the value of the rate. And since it's character, we want to change it into an integer, and we use the function integer for that. So now, then the valve list, there is a the last part of the line is either valves with an S to indicate that there is more than one, or it's valve singular when there's only one. So what I do is, okay, I can look for the text valve using my right index. You can use index that looks from left to right, and right index looks from right to left, because if we look from left to right, you will find that valve is the first word, but I'm interested in the last word. So I look at the valve, where it is in the text, and I say, okay, from this point, I want to have my, I go 6 values ahead, so I come in this either on the first character of the valve list or on the space character. So to be sure that I cut off the space, I do another trim. If I don't specify what characters to trim, it will just trim off the spaces and new lines. And I also have a I step, which is something to use later. Anyway, at that point, the valve list, which I stored in the valve temp table, is now being processed, and I say, okay, I do all the number of entries in the valve list, and as you can see here, It is a standard comma separated list. I just do an entry n, which is like going from 1 to the number of entries, and I take that element from the list. I do the trim, because as you can see there are some spaces, extra spaces, and we don't want them, so trim that. And I create a path from my valve that I've just read, which is the case of the AA, to the value of the valve which is in the list, and that is 1 minute away. Okay, I hope that's clear. We have read in all the valves and all the single step path. Now continue with the subsequent processing of this information. I have to create additional path because I want to know how long it takes from any point to go to any other point. So what I do is I say, okay, I have a temp-table buffer. So this is basically another name for the same temp-table. So I can use the same temp-table in 2 different ways. And I say, okay, for each start valves, first of all, I reset the value of the distances. So for each valve, which is there, I set if it's sorry, if it's the same valve. So if I'm looking at myself, then I say, okay, the distance from myself to myself is 0. Otherwise, it is unknown. And then I do this breadth search to find all the paths going from one point to another. How do I do that? I say, okay, at first step, I set it to 0. So I start at my start point and I say, okay, do a search block, which is a repeat. So I continue to do this until there's some end condition. And the end condition is found new is false. So I say, okay, found new is false. And if I don't find anything new, then it remains false and I just leave it and I'm done. Otherwise, I do this. I look all the other valves where the step is equal to the new step. So I look at my first reachable valves and I join that. So each path that goes from that valve and it has a 1 minute step, and that is the destination where I can go. So to explain it on the board, basically I say, okay, I start at valve A. I know that from here I can go to D, B and E. So I can say, okay, this is 1 distance away, this is 1 distance away, this is 1 distance away. Then I say, okay, for DD, where can I go? I can go to EE and I can go to CC. So that means that from A to EE is like 2 steps. And from A to CC is another 2 steps. So I set the distance from A to EE equal to 2 and also from A to CC equal to 2. Let's look again at the code. I start off by setting all the path distances to unknown. And as soon as I reach a path that I have not touched yet, I know it is the shortest path because I will do all the places I can go with 1 step. Then I do all the places I can go with 2 steps and with 3 steps and with 4 steps, etc. So as soon as I find a node which I have not yet touched, so the I step, the distance is unknown, I will set this value and it will be the smallest value of all the possible paths. Basically this is doing for every valve the path to every other valve and with the minimum distance. So that is the way to create all the possible paths. Okay. Now, another thing that we have to be aware of is that we're going to use the available path to determine the maximum total flow rate. So we can really exclude all the paths that have a flow rate of 0. It doesn't make sense to move from A to F because F is 0 and you're wasting your time. So what I do is I clean up all this useless path to reduce the calculation time. So every path that has a 2 value with a flow rate of 0, I will just delete it. And every path that starts with the valve rate or the flow rate of 0. So I have to delete them as well, except for the starting point of the whole puzzle, which is AA. Okay, so this is just a little bit cleanup to make sure we don't have too many paths to check. Okay, now after that preparation, we remain with all these possible paths, so we can now implement our routine. So the heart of the solution is a recursively called function getMaxFlow, which takes in input what is the current valve, how much time do you have left, and what is the list of open valves. So that gives us a possibility to go to those valves that are not yet open. So this function will look at all the possible paths to go from the current valve, calculate the remaining time based on the distance and the extra minute to open the valve, then opens the valve and calls itself with the next situation, so the next value, the new time left, which is the time that I had before, deducted by the path to go there and the minute to open the valve, and the new list of open valves, which now includes also the one that I've just opened. And we calculate the total flow produced by the next value, which is simply the time left times the flow rate of the valve, and add up that to whatever we have found in this previously called. This getFlow function, as I told before, it takes in input the valve that we are looking at, what is the time left and what are the open valves. And it is very important in Progress to have buffers for these temp-tables. We have like two temp-tables, the path, the valves and the path. And I also have another temp-table, which is the visited temp-table. I will go in that later. But the main routine says, okay, I start off with the max value of 0. Then I say, okay, I find the current valve, and for each other valve, so all the paths leading from this valve to all the other ones, I say, okay, if it's already in the open list, I don't do anything. I just do a next and I will repeat the loop without doing anything. If it is not open, I can say, okay, this is one of the options I can go to. So my time left is whatever time left I had before, and I subtract the minutes it takes to go to the next valve and 1 minute to open that next valve. If it is less than 0, it means that I have come there too late. There's no time left to go there and open the valve, so it doesn't make sense to do anything here as well. So I just do the next again. I don't consider this path. If I open this valve, the next valve, I will add it to my open list, which is basically saying, okay, I get whatever open list I have in input. If this is not blank, I have to first put a comma to say that there will be a new element, and that is the next value, the next valve. And then I say, okay, the maximum value I can obtain is whatever maximum value I have before I started, and I get the max flow of going to this next valve with the new time left and with the new open list, plus whatever I gain from the current call, which is the time left times the next valve flow. And after doing this in a recursive way, I finally get the answer for the maximum flow. There is something to do with this visited temp-table. There's an optimization here. And to optimize it, we store it in the temp-table, the ttVisited, so it doesn't make sense to do twice the same thing. We just retrieve whatever value we have stored from the previous run. And there's a little problem with the list of open valves, because we don't know in what order they are being opened. So whatever situation I have, I need to normalize it in some way. And the normalization is done by putting it in an alphabetical order. Okay, so we need a little function to transform the list of open valves into standard switches list. So what I do is, for each valve, obviously I only consider the valves that can have a flow, so the flow rate is greater than 0, and I will order it by their alphabetical C valve value. And then I say, okay, the switches that we have obtained from all these valves is whatever switches we had before. So if the lookup of this valve in the open list, so it's not open, it means it's closed. So then we put a 0, and otherwise we put a 1, so it's open. So we will basically look at all the valves in alphabetical order, so except for the zero flow valves. So the list will be BB, CC, DD, EE. Then F is not included, G is not included, HH, and JJ. So we will have like 1, 2, 3, 4, 5, 6 valves to put into the switches, and this means BB is closed, CC is open, DD is open, D is closed, D is open, and D is open. So, and this is a standard way of turning the available valves with a flow rate into a singular string with all the switches inside. That makes it easy to store it in the temp table. So what I will do is the switches is the get switches of the open list, and the time left is the time left, and we will do a check if this is already a situation we have had before. So we find this situation, and if it's available, then I can just return whatever value we had during the first time we explored this, this particular path, and we save in the end. So if it's not already passed, then we have to save this situation, which we do again with the ttVisited, creating a record for the valve, time left, and the switches, and the current max value. Okay, to resolve the real input, it took like 17 seconds. Here we are. Okay, here is the program. If we run it, it will ask us for some input. I say, okay, solve part 1, and run it. And in about 17 seconds, if it's still the same workload on my computer, it should come up with the answer of the real input. Have you been counting? Well, it took 16 seconds and a half. Okay, but that's a good time for a Progress OpenEdge based solution. Progress is a language typically used for business applications, so these kind of problems are not the main focus of the inventors of the OpenEdge ABL, 4GL, or whatever you like to call it. But it is nice to solve these puzzles also with OpenEdge. As you can see, I use the temp-table approach. I usually do that. And with a small set of instructions, I finished the part 1. And it was also quite fast. And the second part is that you have an elephant and you instruct the elephant to open valves as well. But again, there is some space left for progress. Okay, thank you for watching. You can go to my YouTube channel. If you have found me here, you probably have reached the channel as well. Subscribe to it and get notified when something new is there. And have fun solving the problems for the Advent of Code. For now, I see you. Bye bye, and see you next time on the Advent of Code solutions in Progress ABL.